Okay, I hope you're sitting comfortably because this one is going to keep us busy for a while. But yeah, let's take a look. So they're giving us a function, and they're asking us a lot of things. So they're telling us it has a stationary point at 2, -13. Obviously, you can imagine they're asking us first of all to find A and B. Then they're saying find the coordinates of the second stationary point on the curve. So let's just do a little write up here what we need to find. So we have to find A and B. We find the other stationary point. Other stationary point. I'm just going to say stat point for myself. If I can spell that. Other stationary point. They're also saying the nature of both points and the nature of the stationary point, and then the last one is pretty interesting. It says find the coordinates of the point on the curve where the gradient is minimum and state the value of the minimum gradient. So the minimum gradient, okay, that's pretty new. Cool. So I think the first three parts should be fairly simple. We have done a couple of these examples before. So let's just have a crack at it. What color, the most difficult part of my day is deciding what color I'm gonna write in. Let's go for red. So A and B, because I have two variables, I'm gonna need two equations. So I'm going to start off with the simple one where I just input these values. So 2, and that x is 2 to the cubed, and then a 2 squared plus b, well, I could have just write 2b, but that's fine. -13, 2 times 2, okay, that's going to be 16 plus, I think, 4a plus 2b plus 7 and the 6, and then carrying it over that side, that should be -36. And what's left here is just 4a plus 2b. And if I want to write, I'll take that over. -36, -4a is going to be 2b. I'll just divide by 2 on both sides. So -18 minus 2a is b. Okay, I think that should be good enough for our first equation. The second equation, let's do that in blue. It's going to be dy over dx. We have to derive because this is a stationary point. We can put in the x value, but let's just derive first. This is going to be 6x squared plus 2ax plus b, and the rest disappears. That's pretty simple. And then I'm going to put in my 2 and equate to 0, or equal it to 0. So that's the 2 squared plus the 4, well, sorry, the 2, and then the a, and yeah, it's going to become 4, and plus b is equal to 0. 2 times 2 is 4, times 6 is 24, plus 4a is going to be, I'm going to take that over and have a negative b. Do I really want that? Let's just divide by negative on both sides, and we'll make these, there we go, -24a, -4a is equal to b. So now all these, oh, look at all these negative stuff. Yeah, let's quickly solve that. So we have -18, -2a is going to be -24, -4a. And let's say if I take this to that side, I'm going to have 2a, and then here it's going to be, what's this, negative, why am I taking so long? Why, this is just a -6. Wow, that took way too long. Okay, so a is going to be -3. And now I can input that anywhere. Let's just put it into this one. That should be fine. -24, -4 times -3 is going to be b. And then -24 plus 12 is b. So b should be -12. Okay, cool. So we found A and B. I'm just going to write A is -3 here and B is -12. Okay, so that part's done. Let's next part, other stationary point. Okay, I'm not going to take the derivative part out because we're going to use that right now. This part I can do. Now it's interesting, they say the other stationary point, so let's just quickly put in the A and the B here just to, well, I'm going to write it here. So dy over dx is going to eventually be 6x squared minus 3 times 2 is -6x minus 12. Okay, cool. So we can take this away. So this is our function, and this is going to be equal to 0. Now, even before I start, because I know it's the other stationary point, I'm making a very good educated guess that one of my factors, I'm just going to put it here, one of my factors will be this. Now, let's just check if I'm correct when we end. Why do I know this? Because I have x is equal to 2, so I'm assuming one of the factors will be that, but okay. We're going to easily just divide by 6 on both sides. We're going to have -x and -2 is equal to 0, and called it. So we're going to have x and a 2 and a 1, and it's going to be -2, called it, yay, and +1. So basically our critical points or our stationary points here would be x is equal to 2, but we already know this one, and x is equal to -1, and they're asking for the stationary point, and they say the coordinates. So I know the x value is -1, and now I just have to put it in there. Okay, but we have to rewrite that function first with all our new variables inside. So 2x to the power of 3. A was -3, so we'll just do -3x squared, and then -12 b, not b, we already put in the b, and +7, and now we can just substitute -1 everywhere. Okay, that's 3, I promise. -1 squared, -12, -1 +7. This becomes -2. That's positive, but this is -3. This is +12 and +7. So that's 5 and 12. 19 minus 5 should be, what's this, 14. Cool. So we found the other stationary point, and that stationary point, I'll just write it here, is -1 and 14. And now we have to find the nature of these points. And the simplest way to do that is just finding the second derivative, because this is going to be very easy to derive again. So dx squared, and this is going to be 12x minus 6. And now we just want to find out whether these would be positive or negative. So I'll do 4x is equal to 2, and for x being -1. So if x is, well, 2 times 12 minus 6, this is going to be positive, so this will be a minimum point. And then when x is -1, we have -12 minus 6, which would be negative something like 18, and this will then be a maximum point. Cool. So that was the easy bits. We've done so many of those before. Now for the tricky stuff. Okay. In a previous video, I did show that in this case we have obviously this one has 2 stationary points. So this function looks like this. It will have 2 stationary points. And let's say this was my x-axis. If I were to draw the gradient function, so this would be f of x. So let's just say if this was function f of x, and this is the derivative, so that would be f dash of x. If I were to draw this, it would go something like, oh my goodness, I had one job. Oh dear. Anyway, forgive me. Let's just say this would line up there, and this would line up there. And this is the gradient function. So basically, I know this is a obviously positive gradient, and then it goes on to to a zero gradient if I look at the blue function. And then this line is going down. It's like a roller coaster, and it's going down, 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 down. And you should know by this time it would have a point of inflection. That is when obviously the negative, it's going negative, but then it's kind of going negative still, but it's increasing. So somewhere here, there's a point where the gradient is decreasing all the way to a negative value, more negative, and then suddenly it's still negative, but it's less negative, and then it's obviously increasing to zero, and from here it's going out. And the question is reading, it's saying, find the coordinates of the point on the curve where the gradient is minimum. So minimum means the lowest gradient. So the lowest negative gradient, and it would be just around here, just before it starts going positive. And that is the point of inflection. Now, if I actually drew this correctly, it would actually line up there. And because this is a gradient function, the lowest point, this is a parabola, right? The lowest point would be this is positive, and well, okay, this is zero. Let's say everything above there is positive and everything below here is negative. So this is the lowest point of my gradient function. So if I want to find the minimum point or the minimum gradient, it would probably be the lowest point on this function. And that point is a stationary point. And if I think about this, for this function, for f of x, if I wanted to find a stationary point, I would derive it and make it equal to 0. And then I'd get an x value, and then I'll know where that stationary point is. And now this is just another function. And if I wanted to find the stationary point here, I would just actually derive that function again, and then make that equal to 0. And then I'll find that stationary point. And that's exactly what we're going to do now. So we're just going to take our second derivative, 12x minus 6. I'm going to say this is going to be equal to 0. And 12x is going to be 6, and x is going to be a half. So basically, where x is a half, if I were to write a coordinate in there, well, there, it would be a half. And that's the lowest point. And it's also the point of inflection. Inflection just being that is when the curvature changes. So when it's going from concave down to concave up. So obviously here, from here to here, the function is decreasing because we're going from a positive to a negative function, value. And then from here to here, it's actually increasing because it's going from negative back to positive. So that point there where it changes, that is called the point of inflection. And that's kind of where we would find the minimum gradient. Okay, it's kind of like going down a roller coaster and you're like contemplating your life choices and thinking your life is flashing before your eyes, and then just at the point where the roller coaster is going up again, or like up again, you feel like, oh, I'll survive, I'll make this. At that point there, you think like, okay, that's the point of inflection, because you're not thinking you're gonna die anymore. It's like things are looking better, still going down, but still looking better. Anyway, lots of talk there. We still need to find the coordinates. So I know that this is the x value. And now I just have to input it into this function. Oh, I think did we wipe that off? Oh dear. Anyway, we'll just write it again. So y is equal to 2, x is going to be a half, plus the a, well actually that's a minus a, right? So minus 3 a half squared plus b, it's negative b again, so negative 12 times a half plus 7. And if you put all of that in your calculator, you're just going to have to believe me, we get a half. So there's the point where the gradient is at its minimum is a half and a half, or you can write it as obviously 0.5, 0.5. So that is the coordinate. That's the one thing they asked. And they also asked the value of the actual gradient. So for that, we'll have to use this the x value we got here. We're going to have to, where do we have now three options. We can put x in here, well, the half in here, but that will just give us a y value, and that's actually what we did here. I can put the half in here, and then that will actually give me the gradient. Okay, so that is where we're going to put it in. I'm just going to rub this off. And we're going to finish off finally with 6.5 squared minus 6 times a half minus 12. And we're going to have to find out what the gradient is. I put in my x value, a quarter times 6 minus 3 minus 12. That's going to be, when we're all said and done, it's going to be negative 13.5. And it makes sense that it's a negative number because it can't be a positive number because we're trying to find the lowest gradient. But this means that whatever is happening, maybe this is plus 13.5 and this is 12 and 10 and 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then it goes to negative 1, negative 2, negative 3, negative 4, etc. And here at this point, it's negative 13.5, and that's the lowest gradient. And right after that, it might be negative 13.4. So it's just a little bit less. So yeah, that was at that point, the gradient's at its lowest, and the gradient value is actually negative 13.5. Wow, that was congratulations for watching through that whole video.